A phone company offers two monthly charge plans. We have Plan A and Plan B. Plan A, the customer pays a monthly fee, so this happens each month, of $4. Then an additional 8 cents per minute of use. So per is our keyword that indicates variability. So each month you're going to pay a flat rate 4 and then 8 cents per, and our variable M, it looks like they want us to use M. Use M for the number of minutes. So we'll label this M as our variable. And in Plan B, there's no monthly fee. So this set or fixed rate for Plan A, this is equal to 0. But the customer pays 9 cents per minute. Here's our indicator of variability per minute. So let's look at Plan A. We have Plan A, $4 plus 8 cents per minute of use. And then Plan B is $0 for the fixed rate and or the monthly fee, but the customer pays 9 cents per minute. So it's asking, it says, for what amounts of monthly phone use or minutes will Plan A cost at least as much as Plan B? So it's saying Plan A can be at least as much, meaning it can be equal to or it can be more. So it can be equal to or it can be more than Plan B, but it has to be at least the same as Plan B. So we're just creating an inequality. Remember, this sign right here literally means if we have Plan A, we want Plan A to be at least, meaning it can equal or it can be greater than Plan B. And that's how we get this greater than or equal to sign. Okay, so let's look at it. Here, notice we're dealing with dollars and we're dealing with cents. So we want to make the units the same. So instead of having cents, let's make this dollars. 8 cents would be expressed as, let's look at Plan A. Let's make an expression for Plan A. Be $4 plus $0.08 or 8 cents per minute, M. And then Plan B is going to be 0 for our flat rate. However, it's going to be 9 cents or $0.09 per minute. So if we set these into this inequality, we've got 4 plus 0.08 M should be greater than or equal to 0.09 M, which is Plan B. And then we can solve for M. It says use M for the number of minutes, and then we've set it up, and then solve the inequality for M. So now we need to just solve this. We can deal with the decimals. It looks like it'll be easy to deal with the decimals instead of creating integers out of them. If we wanted to create integers, we could multiply both sides by 100. That way we're not dealing with decimals. However, it looks like we're really close here. We can just deal with this. Let's go ahead and subtract, use opposite operations to subtract 0.08 M from both sides of our inequality. 0.08 M. And when we do that, of course, this is going to cross out. We've left with 4 is greater than or equal to, because we just subtracted, nothing happens to our sign, 0.01 M. Now, if we wanted to go ahead and, it's fairly simple once we divide 4 divided by 0.01, when we use opposite operations, we can go ahead and just plug that into the calculator. Or if you wanted to, if you don't have a calculator and you just wanted to deal with integers, of course we could multiply both sides by 100, giving us, let's go ahead and do that. We'll multiply both sides by 100. And it looks like I'm running off the page, so I'm going to come over here with it. That would give me 400 is greater than or equal to 100 times 0.01 m, move the decimal 2 places, is equal to m. And we are done. We would get the same exact thing if we were to divide by 0.01. If we wanted to divide both sides by 0.01, 4 divided by 0.01 would still give us 400. And nothing happens to our sign because we multiplied by a positive number or we divided by a positive number. And the number that we would need minutes-wise in order for Plan A to be at least as much as Plan B is 400.